course schedule and the problem, its second part, course which is course schedule 2. Now I will explain you both of the problem one by one. Now it says now there are total of num courses. Means this is the number of course you are having. You have to take labeled from 0 to new courses minus 1. These are the indexes of vector or array. You are given an array of prerequisites. The prerequisite of I is defined as this AI BI indicates that you must take the course BI first. If you want to take course A of I, means your B is dependent on A. If you take the course A, then you will be eligible to take the course B. For example, the pair this indicates. This is explained similar to the above one. You need to return the true if you can finish all the courses, otherwise return false. So in this question you have to find the tag graph. And tag graph we can use the topological sorting order. But here we don't need that. We need to return true when we can find the means we can take all the courses, then we return the true. When we will not be able to take all the courses, then we return the false here. And there are two examples, two courses, and output true. There are total of 2 courses to take. To take one, you should have finished the course 0. Yes, so it is possible. Now we have this second example. Read this one, and there are the conditions given below. Number of courses can go maximum up to 2000, and prerequisites at vector array length can go up from 0 to can go maximum 5000, and prerequisite of I dot size. It means we are having the, I guess, pair of 2. And AI, BI can go up to from 0 to num courses. All the prerequisites are unique. So now I will go and go towards the explanation of problem which we have started. This is the function which is given to us to implement. We have to complete this function. Here and various vector is pass given to us as the input. This n is the number of vertices or nodes, and this is age. Age is vector. So what we will be doing is, inside this, we need the associated vector, and initially, we mark all the nodes by the false value, and we make the recursive path. Same thing we done with this recursive path vector. All node false, and we run the nodes on the neighbor here. All the neighbor nodes from 0 to n. And d are equal to 0, I less than I plus plus. Inside this loop, we have checked the condition. If neighbor is not visited, we will call this function. It's cyclic DFS. We are checking the cycle condition using DFS recursion. Okay. We have made this function. Just before this function, we have called this function for the node I and marked that node I as visited and its recursive path. If it again comes, and it is obviously. So these are the 4 parameters of that function, this cyclic DFS that we made before this function. So if it means if this condition is true, since it is placed inside of, so there is cycle exist. Because this is a cycle, so we will return false here. And this, so by after the end of this for loop, if cycle not exist, we will return the true. After this, I will explain you the above function. Let me explain now. Let me explain you the function is cyclic DFS, which is written just before this function can finish. This is the custom function we use to check the cycle. Here in this function, we pass the source visited and path, recursive path. From some information from this function at the top function, source visited and recursive path, and it is and initially mark the visited true, and in this also we mark it true. And here we are not running in this cyclic DFS function, we are not running our loop on the neighbor. The long reason is explained here. Just cut this line. The logic starts from here. That we don't know here कि source node के कौन से neighbor है, क्योंकि हमारे पास edges की information है, वो scattered है. Because यहाँ कोई भी node इधर से उधर dependent है. एक node से दूसरी node पे arrow है, एक से दूसरे पे. तो we can check for all edges. We have to check for all the edges. 0 to edges dot size less than edges dot size. We have to run the loop at the all edges. Here inside this edges loop, we made the neighbor as v, which is edges of I comma I of 0, and u as edges of I of 1, which is source. And after determining the neighbor and source, from this condition we say we found the source node u equal source. Then means we found our source. Now inside it we check the condition. If we have not visited the neighbor, then we will call this function is cyclic DFS. Similar recursive function inside this function for v. This is source here. V means earlier our source was u. Now if our neighbor was not visited, we visit the neighbor v, and this time our source will become v, and we mark it as visited and mark it on the recursive path and edges and return true. Because there is cycle, we return true. And this is the after this outer if we have written the else if, which is else case of this neighbor not visited. This condition is when neighbor is visited. Neighbor already visited hai, and we have the recursive path of v. Neighbor means I guess it is coming twice, so that's why there is this condition is of I guess baggage condition. So there is cyclic present, so that's why we return true. And at the end we delete the source node. This is the step of backtracking and deleting. We backtrack and delete the old nodes and return false when we don't have found cycle.